Hey there, let's take a look at climate change and its impacts on the carbon cycle. Climate change is causing changes in climate zones across the world, particularly with the increase in areas suffering from drought. Changing climate belts. Changing in temperature impacts the air circulation system. The current system sees low pressure and high rainfall at the equator, with high pressure and low rainfall at the poles and at 30 degrees north and south. A change in temperature may cause these systems to shift in a different position, leading to rainfall patterns changing. With a 2% increase in temperature, 5% with a 2 degrees C increase in temperature, 5% of the world's climate zones have changed. A further 2 degrees C increase would see a further 10% shift in climate zones. Human causes. Human causes of climate change include the enhanced greenhouse effect. The enhanced greenhouse effect causes an increase in global temperature. Greenhouse gas emissions increase because of the burning of fossil fuels and carbon stores are reduced, because of human activities such as deforestation and urbanisation. Frequency of droughts. Because of the shift in climate zone, the areas that are cold are decreasing and the areas that are dry increasing. The arid and semi-arid areas are likely to expand further within continents such as sub-Saharan Africa. Europe and Western Asia are seeing the highest threat from the risk of drought. What percentage of the world's climate zones have already changed within a 2 degrees C increase in temperature? The correct answer is 5%. Ocean acidification. The process where the oceans become more acidic can have disastrous impacts on the ecosystems that exist there. What is ocean acidification? Ocean acidification refers to the process of more carbon dioxide being absorbed into the ocean, which means the pH increases, meaning it becomes more acidic. When there is a higher concentration of CO2 absorbed in the ocean, it converts largely into carbonic acid, which has got the chemical formula H2CO3. But if there are lower concentrations of carbon dioxide when the CO2 is absorbed, the carbonate ions promote healthy coral growth. Impacts on other life. If coral reefs are lost, there are many other animals that are dependent on them. Coral reefs provide shelter for 25% of marine species. Coral reefs can provide shoreline protections from storms and large waves. The fish that live in the reefs can support local fishing industries, and tourism can thrive around coral reefs, especially where scuba diving and snorkeling are possible. Impacts on coral reefs. Algae, which live in the tissues of corals, provide carbohydrates to the corals through photosynthesis. A byproduct of the algae gives the coral bright, brilliant colours. Corals can only survive between 23 and 29 degrees Celsius. Coral bleaching happens when the water is too warm, causing algae to be ejected and leaving the coral white. Climate change is a leading cause of coral bleaching because ocean temperatures continue to rise. Additionally, acidic water makes coral disintegrate. So the effects of ocean acidification are coral disintegration and bleaching, tourism decline, such as scuba diving at the Great Barrier Reef, storm surge and waves where reefs would protect shores, reef fish have no habitat, and local fishing industries decline. What does carbon dioxide convert to when there is a high concentration of it absorbed into the ocean? Is it carbonic acid, carbonate acid, sulfuric acid, or hydrochloric acid? The correct answer is carbonic acid. What's the effect of temperature on water and carbon stores? Increased temperatures are likely to cause the most impact to cold regions, like those found within the Arctic Circle. Increased evaporation rates. Changes in global temperatures result in increased evaporation rates. This is simplified into the phrase, wet get wetter and dry get drier. Changes to temperature could lead to changes in the air circulation system. This could result in tropical storms moving further away from the equator as sea surface temperatures reach 27 degrees C in places further away from the equator. Stores. With increased temperature, there is a rise in the rate of evaporation and so in water vapour. But, due to warmer temperatures, the precipitation falls as rainfall rather than snow. The higher temperatures also mean the snowmelt begins earlier. This can alter the river regimes, with higher river discharge in the winter because of high amounts of rainfall and spring snowmelt happening earlier. Drainage basin stores continue. Thawing of permafrost regions can lead to water infiltrating and percolating deeper. Before this, the water would have been unable to infiltrate the frozen ground and instead been surface runoff. So let's quickly recap all of that. Changes in temperature could lead to changes in the air circulation system, which could result in tropical storms moving further away from the equator as sea surface temperature reaches what kind of temperature? Well, 27 degrees Celsius, which is the temperature needed to have tropical storms, in places further away from the equator. Some effects of increased temperatures are precipitation falls as rainfall rather than snow, snowmelt begins earlier, rise in the rate of evaporation, and changes to the air circulation system. Let's have a quick look at threats to ocean health. Ocean environments provide food, protection, and income for the communities that develop around them. To keep these goods and services, the health of the ocean is of the utmost importance. Tourism surrounding coral reefs have always included scuba divers and snorkeling to see the beautiful colours and fishes. Coral bleaching has been seen in Australia's Great Barrier Reef, which can impact the tourism industry of these regions and can lead to a spiral of decline. Oil spills, though less common, are devastating to coral and marine ecosystems too. Developing nations. The poorest nations will be the most dependent on their oceans as food supply and income. Climate change results in changes to coastal environments, which leads to changes in the location and amount of species, with knock-on impacts for the rest of the food chain. The North Atlantic has increased in temperature, and the plankton that is used to cool water dies. The plankton that is used to cool water dies. This has a knock-on impact on the rest of the food chain. Coastal protection. Mangroves provide significant coastal protection and are found along tropical coasts. They bind together sediment with their extensive root network, protecting the shore from storm surges and preventing erosion. 50% of all mangroves have been lost since the 1950s. This is largely because of tourism, as the mangroves can be cleared for tourist-friendly beaches and hotel developments. But this leaves the coast exposed, as seen in northern Sri Lanka on the 2004 Boxing Day tsunami. What percentage of all mangroves have been lost since the 1950s? The correct answer is 50%. Where in Australia has coral bleaching been seen? It's been seen in the Great Barrier Reef, which can impact the tourism industry and lead to a spiral of decline. As climate change shift, which regions are likely to expand further within continents such as Sub-Saharan Africa? The answer is arid and semi-arid regions. What are the temperatures the coral can survive between? There's between 23 and 29 degrees. Coral bleaching happens when the water is too warm, causing the algae to be ejected and leaving the coral white. Coral can never survive below 18 degrees Celsius. One example of the effect on temperatures is in the Yukon region. This is in northwestern Canada. Northern parts of the region are in the Arctic Circle, while the rest is in subarctic territory. Changing climate has resulted in higher rates of winter precipitation between 1950 and 1998, with projections of a further annual increase between 5 and 20% by 2100. The area covered by ice has reduced by 22% between 1958 and 2008. This has seen glaciers retreat. Let's quickly recap mangroves. Mangroves provide significant coastal protection and are found along tropical coasts. They bind together sediment with their extensive root network, protecting the shore from storm surges and preventing erosion.